Welcome to this walkthrough of the What is Python notebook I've put together for you. This is just high-level introduction to the tool, just so you can see a little bit of what is Python, the programming language, and start to get a feel for what we might be doing in later instances. Now, you need to know that this was built with generative AI. I gave generative AI all the context that I needed an introductory workbook in Python and that I wanted to teach basic capabilities. So you just need to know that because this may look daunting. You're going to see a bunch of really detailed written out code that you might think, oh my goodness, how am I ever going to learn how this happens? That's not how this goes anymore. How this goes now is you have a task and you understand the capabilities of Python, and so you ask it to accomplish those things. And then you are the observer, you are the supervisor to see, did we get to the end result that we needed? Even, Google is making it so that some of the prompting, some of the working on code is happening right here in the tool. So that's the thing. So, okay. Number 2, Python is a programming language. And where you run Python is a ton of different places. Now, I've chosen a location and a version of how to use Python that makes it really easy for you to access, okay? But don't get confused and think that this is the only way to run Python and that this might look different than other examples that you've seen. So where am I running this? I'm running this in Google Colab. So if I were to go to Google Colab, I'm going to find that this is a tool that Google has for an introduction to Python, and it's this opportunity to run code in the browser without having to worry about any of the other details. So that's why I've brought you here. The other way that, myself, when I'm running code, I'm running it in something like Visual Studio. That is my main IDE or development environment, basically, where I personally am running code. So I would come to a program like this and be writing and executing code there. There's a ton of different ways this might go, but this one is the easiest so that you don't have to worry about basically anything or putting anything on your local computer, and you have a space to program and build stuff. So this is what's called a Jupyter notebook. This helps make code come together in a more readable and discoverable fashion. You're seeing on the left-hand side here, there's like a table of contents. That table of contents is created because we've got these chunks here that aren't actually code. If I were to go to edit, you're going to see that this is a text block, and it's formatted with little symbols like this to make things larger or as a header. It's formatted with little symbols like this to make it bold. And so a Jupyter notebook is just a combination of code and text. You can see that you can turn this into code or turn this into text so that you can bring together information like this. You can have a title, you can have sections, you can have this outline, so you can jump down to these different pieces, and you can put with that code. So I've got a little bit of context here. What is this? What are we going to do together here? And where are you working? And then we go down and we run some code, okay? So let's do our first bit of code. So this is the first block that is code that was created just by saying, add a block of code right here. And guess what? You can start by generating with AI. You can give it a prompt to say, I want a block of code that does this. So let's just do that, okay? I want a simple block of code that shows how lists work. Okay? Let's see what we get. That's what's in the rest of this document, and we'll run through the stuff I've prepared. But I want you to see that this is how this can work now. This is not me writing code. This is not me perfectly understanding, this. This is me using generative AI for what it's good for in order to accomplish code. And I've just gotten to code that works, and I've just run it. So here's an example. I haven't saved it. That's why this looks so kind of interesting. And I'm going to get rid of this because we're going to go back to my example. But look, I've just drummed up an example for you. It's gone and made a list. It's named it my list. And it is this short set of numbers right here. Okay. And then it says print original list is equal to my list. And you see down here, the first result that returns in this cell when you run it is a printout of the string original list, which you see here as the first item, and then the variable my list, which is that list right there. After that, it goes and does a couple of things. It appends the number 40. It prints out the first element, showing you that you can access different elements in the list by indexing it in this way. So now it's going to print my list, and in brackets there, position 0, which is the first position in the list. It goes from there, 0, 1, 2, 3, so on and so forth. Then it does a small loop. So that's just to show you that's how this actually happens now. But let's go look at some of the pre-made examples I have in the code for you. Number 1, lists. I show you how to use a list. And I'm actually also showing you how to declare a variable, basically. Here we are just making a variable by saying numbers is going to be equal to this. What that does is in our code from now on, as soon as I run this, anytime I use the term numbers, it will refer back to this variable we have set, which is a list. And so that is why when I write a statement like this, print out first the string numbers with a colon, and then the variable numbers, I get whatever numbers is. So right now, numbers is a list that is 3, 6, 9, and down here you see numbers and 3, 6, 9. If I add to this and add 10, 11, and 12, now when I run this code, it's going to print what numbers now is, 10, 11, and 12. But let me show you one other example here. Oh, sorry. Gonna get rid of that change I make because I just want to get it back to the base. Okay, so that's that. I'm going to pause there. I could go forever on each of these, but that's a basic concept of what we can do with a list and how we can refer to that list or make it a variable and use it later on in the code. That becomes an important concept. Next, we can do math. I'm going to show you very basic math, which you probably wouldn't necessarily need to be doing here in Python, but it extends, right? You can do this now with all the other pieces and parts of the code that you use. So some basics, we're going to declare some variables. A is going to be equal to 10 and B equal to 4. Then we'll add A and B. We'll subtract A and B, multiply it, and divide it, and we're going to see what the results are. Total is 14. The difference is 6. Product is 40. And the quotient, I don't know what divided by, 2.5. So that's an example of declaring a variable and then using that variable to do basic math operations. And you're seeing that we're making each of these a variable too. We're saying, let's make the total equal to this math operation. And later on, we can refer to that. We can say print out, the total, print out that difference, that kind of a thing. So you're seeing some basic principles play out. Next, you can do math across something like that list. Remember that numbers is made up of this list here, 3 and 6 and 9. And so when we use it with mathematical operations, like what is the sum of that list and what is the length of that list? It's 3 long. We can do something like calculate the average of that list. And so now we see that the average of 3, 6, and 9 is 6. And then we'll use it down here with some logic just to show how we do some basic if-else type of logic in Python. Another core capability of what we can do with this technology. So you're seeing that we set a variable of threshold to be equal to 5. We're going to check and see if the average, which we calculated up here of this list, is greater than the threshold, let's print the average is greater and give the threshold. If it is not, it does not evaluate to true, then it'll move on to this next statement and it will print the average is not greater than. So when we run it, we find out because we know it is an average of 6, we do get that proper result. The average is greater than 5. So this is us telling the computer to evaluate something, find out if it's true. If it is true, take one action. If it isn't, take another. This is some really basic capability of what we do in Python. Next is a core concept called a loop. This allows us to take a variable like numbers. Remember, numbers is a list, 3 and 6 and 9. And we can loop over that variable. Because there are multiple elements in it, we can do something to each element. Here we're going to name what we will refer to each element as. So we could name this anything we want. Right now, you're seeing we're saying with this code, for each element in the list numbers, which we will call n, do this thing. We want to take n times itself. We are going to call that squared. And then we will print out the square of n is, and we'll get the value. So what is going to happen is it's going to go to the first item in the list, which is 3. And it is going to calculate the square of 3 by taking 3 times itself and getting 9, and storing that as the variable squared. After that, it's going to print out the square of 3 is 9. You see that as the first result. But now you're going to be thinking, if you're newer to Python, hold on, why did it do this next thing? Well, this is a loop. And we are in a loop because we use that word for. That's a really key word. You can see it's colored different in the code because it is this keyword that is illustrating that we're going to be making a loop. And so what it will do is it will evaluate and do this action, this set of actions that is indented for every value in numbers. So when it finishes with the first value, which is 3, it comes back to the top and does the same action for the next value, which was 6, and the next value, which was 9. So this is how we ask code to repeat a task on a set of items until it is done. A very, very core concept of how we ask the computer to accomplish something. Go and do this thing over this list is the basic what's going on. And it's pretty readable, right? You can see for each number in numbers, do this and then print out the answer, and the result follows. So there you go. You've got a loop. That's a really basic first core concept. All right, next we are going to move on. It's going to get more look much more complicated, and it is. But remember, number one, you can write this with generative AI by stating a goal and giving it the information it needs. Number two, I'm just showing you this now to demonstrate the versatility. Because I've shown you those really basic things, and you might be thinking, well, what that's so basic. I could do math in Excel. I could do math anywhere. That is the very, very tip of the iceberg. So I want to just show you some of what's underneath the water, right? Where is the bulk of this? So this is where Python becomes very powerful. Number one, connecting to data. Here I am setting up a connection to Google BigQuery. Just to make sure that it's available, I've gone at the end of this code and printed out that status, and it is. So that's fantastic. So next I want to get a small data set. So my goal is going to be to have a table with admissions, discharge, and MDC category in order to get BigQuery. So we're going to use what is called a function, which we'll look at in later classes in more detail. But we'll have this function in order to get a sample data frame. And later on, we will call that by making this data frame by calling that function. So what is that function going to do? That function here is going to say, if BigQuery is available, I want you to try this. Go to BigQuery, and you have to start the client. Define the client here. This is part of the BigQuery library that helps us do this. And then next we have a query, which is equal to this here, this string here. Select these things from this data set. This is our HPS encounter data set we've been working with. Next, return the result of that query. If you don't get it, then print out, that you were unable and it failed. Then we have a fallback sample, just in case if that's not working. So I think that's actually what happened here in this code, and so I've got something to fix. So the next time you come back and see this code, I think you're going to see a different result because I don't want that fallback. I want this to work from our data set, and I probably just don't have it wired up correctly. So I'll get that working for you by the time you see this code, but you're going to see probably that's what actually ends up happening is it shares that example. But that's okay. We'll work towards getting it working. I didn't realize that when I started this video, but thanks for hanging with me. So we run this and it goes ahead and will gather the data from BigQuery. That's what you'll see when you do it, but right now it didn't quite do that. And so next we can start working with that. So now we've got that in this item we named DF, just short for data frame. It can be absolutely anything that you want, and the best practice is to name it something meaningful. So the next thing I'm going to show you is with that data frame, we can now do things like calculations and math. So let's calculate length of stay here. Let's start by just getting admissions and discharges into the right format. We're going to get it into this date time stamp, and then after that we're going to make a new column in the data set called LOS days. And you're seeing that we are going to do that by taking the column discharge minus admissions with this .dt.days, which is from a library here in Python that understands how to operate with date time stamps and give us what we need. So again, you don't need to know every single detail about this. You need to know the goal. I have a table. I want to calculate length of stay based on admission date and discharge date, and generative AI helps you accomplish this. Okay, so we've got that, and we are just going to show that we've gotten to the answer by looking at the top of our table here. And so here I'm just saying, show me that data frame with these columns. Sorry, I moved it. And this dot head is going to show us just the top few record in that table. So now you see the table that was there before with the first 4 columns, but you see a new column that has calculated the difference in days between admission and discharge. So this is where that simple math becomes really, really strong. I mean, you really can extend and go to the limit here. You can imagine this could be a table of many millions or even billions of records, and you can instantly get to the length of stay in this way. So that is a core capability I wanted you to see, and I've got 2 more things to show you. Number 1, we can group by and calculate different things on our data. So here's an example where we are going to group by that MDC name and take a look at length of stay, and we're going to take the mean of that and get to an answer of what is the average length of stay by MDC in this data set. So you can see that with a bit of code, now we can take this data set and start doing some calculations. The type of thing we might do with SQL, we would do obviously with visualization softwares, but it makes it available here for exploration within Python, which is very, very powerful, especially once we get to massive data sets, huge data sets that the other tools are going to struggle with. Even when Tableau might struggle, this is going to be something that Python can handle with millions or billions of records far, far quicker than the other technologies. So this is extremely powerful. And this small example doesn't exactly demonstrate that, but it shows you the capability that's here to do that. Okay, I'm going to take just one last leap with you. Outside of being able to group this information, we can display it. We can do visualizations in Python. So you see that there's a library, Plotly, that we use, and we take that result that we had just found, which was the average length of stay by those groups, and we make a chart. We make this nice chart with a nice title, and we have gone from accessing data that could be massive, right? Creating and calculating a new column for length of stay, grouping and averaging across some meaningful group there, and bringing it out to a visualization. So that may seem like, well, those are basic things you can do in other tools, and you're right. But in Excel, you're limited to 1 million records, 1 million plus, and it's very non-performative. In Tableau, you get to use many, many more records. But guess what? Data keeps growing in healthcare. And I said that the very top basic things that I showed you before were the tip of the iceberg. The truth is, this is the tip of the iceberg. There is an enormous amount of capability that you can still accomplish with Python, including where we'll be headed later in modeling and doing predictive analytics. So this is where we start for accessing data and starting to manipulate it, so you can just get a feel, an intuition of what Python is capable of before we move on to the next core thing.